let's jump to this stuff because it's so fun. And this is an or statement, so as long as it's part of one or the other, we're good, okay? So I'm going to start with this one on the left. I'll solve it in red, and then I'll graph it in red so that we can keep track of what we're doing. I'm going to keep my x's on the left and then the numbers on the right. Now I'm doing this with a little bit more purpose than just to do this randomly or to just always do it. By putting the x on the left here, it's going to guarantee the coefficient of x to be a positive, and then I will not have to flip the inequality. So in this process, I'd have to zero out that plus 4 by subtracting 4, but if I do it to one side, I got to do the other side. Also, the negative 4x, I'll have to zero that out by adding 4x's to both sides because it's on the numbers side of the line. So that'll zero that out. 4x's plus 4x's is 8x's, and that does not affect the inequality. Negative 4x's plus 4x is 0. 52 minus 4 is 48. So right here, I'm going to divide both sides by a positive 8. That means the inequality will stay the same. I now have x is less than 6. I'm gonna roll with it on this next one, on the next inequality. But so I, not really that I'm forcing it to happen. It's just going to happen because I'm going to keep that setup the same. So, right? Well, before I do the number line, actually, I should solve the next one, just so I know what values to put on my number line. So let's see what happens here. I'll do this one in purple. I see that I've got some distribution there. So two groups of negative 3x's would be negative 6x's. Two groups of negative 7 is negative 14. No other distribution is required here, so I'll have to drop that. And I think some of you can do this without all these steps. If you can, that's fine. But I got to combine these like terms. Negative 14 plus 6 would be a negative 8. So now I got negative 6x minus 8 greater than or equal to 10x minus 72. Principles of equality here. So I'm just going to stick with x's on the left, numbers on the right. And by doing that, it should force the coefficient to be negative. If you don't want that, then just put your x's on the right. It doesn't matter. So we'll have to add 8 to both sides because the negative 8's on the wrong side. And we'll have to subtract 10x's from both sides because the 10x is on the wrong side. So that'll zero these two parts out. Negative 6x minus 10x would be negative 16x's. Again, addition and subtraction will never change the inequality. And then negative 72 plus 8 is negative 64. Oh, that's convenient. Because next, when I divide both sides by negative 16, and this at this point it's good to notice, we just divided both sides by negative. That now flips the inequality. It's no longer greater than or equal to, it's now less than or equal to. I have a phantom 1x is less than or equal to 4. Okay, so now that I have both those values, I'm ready to graph. I like to see where 0 is on the graph just to help me keep track of where the numbers are getting bigger or smaller. And we're comparing 4 and 6. Now notice I didn't put any other values on the graph because I'm doing it by hand. I don't really need to. 0 is a nice value to have. So starting with the red inequality, I got x is less than 6. So that'd be an open circle at 6 because it's not equal to 6. And this one's not eating the x, so my red line is going to go to the left. Now I'll do the purple inequality, so that's x is less than or equal to 4, so that would be a closed circle at 4. But it's not eating the x, so that goes to the left as well. All right. Now this is an or statement, which means that the purple line that I have here is already part of the red one. So it's included in the red inequality, which means that really the only inequality I needed was this one. We actually don't need this one. In fact, the purple line as well is not really necessary. When you graph this, just graph one line starting at 6, going over to the left. And then last of all, let's make the integral notation here. So I'm graphing the green because that shows the or statement. This goes all the way to negative infinity, which is never included, and then ends at 6, which is also not included. So we have the inequality, which we've boxed in. We don't need the x is less than or equal to 4 because it's included. We have the graph, and then we have the interval. Just as a general rule, usually for or statements, this would usually go this way, but it doesn't always have to, just like we see there. If that were the case, then I'd have to show the interval for the purple and then the red one would have went this way, and then the red. But I'd have to unite them between.